Welcome. Okay. Early early to rise, early to talk about this. Barely slept, so it's not like I am like doing great. Anyway. So I decided it would probably be useful to investigate geologically the the literature type of understanding of Hawaii. And I, not that I made it to literature, but I started just watching YouTube uh, geology Hawaii videos maybe here. This one's pretty good. But they said, so this is all from there, from this one, which is has geologists in it and seems pretty technical based. But they said there are several mountains on the main island, or mountains, volcanoes, and this one here is Mauna Loa right here. Mauna Loa has 100,000 square or cubed kilometers of volume. So that kind of makes sense if, like, this object, generally speaking, like the mass over here is like being like pushed over this way. Not the mass, the liquid, the hot magma, the viscous. I always get the words backwards. I think high viscosity is like corn syrup versus water. I might be having that backwards right now. Um, but it's in comparison, so 100,000 cubed kilometers. I think it was kilometers. It must have been kilometers. Because in comparison, Mount Fuji and Mount Shasta have 10 to 100 cubed kilometers. So 100,000 compared to 10 to 100. So this thing is massive. And not only is it massive, it has a divide and a like really dense mass here with this divide. Almost like this is like a positive separator negative, where the negative is like a liquid, so like an electron is kind of like an electron cloud, where maybe a nucleus is more of a nucleus, relatively speaking. So there's that. Here's Mauna Loa, and then Mauna Kea here is actually slightly higher. So the like positive to the negative is slightly higher. Said to be the highest mountain on Earth, including of the underlying elevation from the seafloor. It's almost like this pillar that just holds the island up in some way. Um, and maybe even the whole of the island chain, relatively speaking. So old that not all the magma from one flow, but is potholed by cinder cones. So there's all these cinder cones. I'm not sure if I agree with that assessment. I really think it's because this is like this side, generally speaking, exploded energy past this boundary, pushing over here into like this boundary, and then squeezing a channel through this boundary. So there's Mauna Kea, and obviously there's way more information. I'm just scratching the surface. I'm just going through these notes to get to something I did yesterday, that I really want to talk about. But before I talk about it, I just thought I'd go through this. So then there's Kohala, which is over here. I believe I wrote down northeast, but I think it's Northeast corner. Oh, yeah, I guess I need labels. I think it was the other corner, though. Even though I wrote down northeast corner. I think it was over here. Kohala. So this one is the oldest volcano on Hawaii. Long extinct. So this one's considered to be long extinct. And then there's another one here, which we'll get to. Pololu Valley. So here's Kohala. Here's Pololu Valley. And over here, Waipio Valley. And essentially they were talking about this stretch here. Where corresponding on the other side of the scarp is Waipo Valley. So in this region, cliffs have abrupt change in topography. They're very much like they remind me of like I want to say the Elephant Rocks. I'm not sure if that's the right name. Something in like Thailand or somewhere. Whoa. Like this kind of structures, but just, and that, just kind of steep. Okay, with that in mind, submarine slopes are steeper than those seen, I guess seen, yeah, seen. I was like, what did I write here? Those seen on above sea level volcanoes. The slopes on above sea level volcanoes are not as steep as the ones, generally speaking, at least in Pololu Valley. Underneath the volcanoes, this is interesting. Underneath the volcanoes was 100 meters of clay that accumulated on the surface of the ocean and underlies the volcanoes. I think they just said it like that. So it's unclear if it's the totality of Hawaii like that. But I wouldn't be surprised, especially because of something I'm going to talk about in a bit. Geologically, it behaves like Greece and encourages large landslides to form. Pukahola Heiau. Oh yeah, that's somewhere they listed. Essentially, there's a volcanic sequence somewhere. I think I couldn't find this one or much. They didn't talk about it extensively. I think it was along the boundary. Maybe like not. That's not it, but it's some name similar to that. Just said it. Hamakua volcanic sequence. Okay. And then Wupop or Puwawa. 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 This one is referring, actually, this whole area is named that because it's this structure here that I've been talking about already, the shallogram feature. So Puwawa, this shallogram feature is interesting. Only one like it in Hawaii. Eruption feature, about 100,000 years old. Explosive feature made up of layers of volcanic ash. Not basalt like most of the island, but trachyte, especially large in potassium, sodium, and also having a large silica amount. Common in continental areas like western United States, which probably is associated with its formation energetically. Maybe even it's like from Yellowstone or one of those novas off in the west coast, like kicking off this chain of events of breaking Hawaiian Islands away from the coastline, closer to the coastline, something of that nature. Hualai volcano. So that was this one. Here's this. Here's this. Hualai. Lalai. Apparently they're associated. This little it's got a beam that goes that way. Just kind of reminiscent of something I'm going to talk about in a bit. Which I'm almost to. Okay, good. This one, though, here, just kind of looks just like a line that's widens and has like two sides, like a shallogram even, to a little extent. It is the second oldest volcano on the island here, but apparently had an 1802 lava flow and possibly others more recently that they didn't list and I didn't bother to look into. Expected to be older than Mauna Kea, so this one is thought to be older than the nucleus over here, which is interesting. Thought to be older than, and it's less, and Mauna Kea is also less active, so that makes it surprising because it's older but but more active. And then they said, for some reason, has remained active for a long period of time, even though it must have started as a volcano on the ocean floor before Mauna Kea did. Okay, and then there's a bay which I couldn't re-find it. Like if I search here, it's not gonna work. Oh, there it goes. Here it is. Pardon me, I found it. Here's a bay. Here. Over here. Which initially I thought maybe it has a landslide that happened about 100,000 years ago, radiometric dating that is detectable because it pushed out material in the landslide that is deposited on these two islands. So interestingly, this landslide is like physically this way here. Like it, unless it slid this way, like, or generally like this way, but it's named after this region, so I'm thinking it went that way. But apparently there's like the reason they know is because there's deposits here, sedimentary deposits in that time frame on these two islands, Kaho, Oleo, Laui, and Lanai. Okay, now that we've gone through the little bit of research I did, I wanted to now bring this up. I was like, what if? What if? Why did that? Oh. What if I just take this lasso thing, cut the boundary of each one of these after taking a picture of it, measure the width across the picture of the actual islands, measure the width according to Google measuring, use that as a basis for determining how the size, the width of the pixels for each island, and then start turning them and just kind of like a puzzle, moving them around, trying to see like how do they fit together. Is there a way they fit together? I feel like they were together. I feel like they were, and then I started to like kind of just take the pieces out, and I realized I really got to turn them around and stuff to really fit them in, and I kept moving them and moving them, and maybe this isn't like the final result of how I would claim this was at some points, but it's approaching it, because if we start down here, I was mainly focused on this island. There's definitely a current coming this way. I called it the eastward propagating current, just westward, essentially coming out from underneath North America and coming out from underneath Asia, pretty much. Colliding between the two continental shelf materials, but the one over here is creating a flow through currents. But not only that, it divides the current off this way and off this way, and generally up here and then off this way, like to this point. It's still kind of is it going over here. So on this island, there's that kind of thing going on. And then also this over here and here too. So I started moving them around, and I was like, well, there's this current here, it just goes somewhere. That's what I started doing. Like, this goes somewhere. Where could it go? Well, it could go right into this one where there's this, like, current going into it and then seemingly splitting and going straight, but splitting, and where it goes straight, it continues through subtly. So here we are, kind of maybe putting it there just out of curiosity, pretty much, and then realizing, oh, well, this island fits in pretty well there, and maybe this one does too. And then once I put these ones in, this one almost like just flowed out of it, and this one, because this one I was moving around. Like this has, let me just talk about the islands and my thoughts before I talk about their arrangements that I settled on last night, for at least temporarily. I'm not completely certain. So this had that current that way. Unique features about each one. This one has that to really help distinguish. And also this, like, divide here. It's almost like this and this were dividing by a current that just didn't fully divide it. Not much to talk on in terms of, like, currents crossing. Maybe here, but that getting stuck in there or something. But here, this tab kind of thing is strongly suggestive that there was just generally a landmass adjacent that, like, broke away from it. And also just this curvature here is maybe useful in this region, being the type of terrain it is. And then over here, initially I was like, well, this thing looks maybe like it was associated to this thing. So initially I started to kind of just put this here as if it was like a here. And it kind of made sense to a degree, but it wasn't quite fitting as much as the current one is. This one I noticed has generally a stream across here, one way or the other, or both ways. Unclear. And then also along this boundary has this going on. It's not just this, but also this. And then over here, this one's got like a little X, which is interesting. And then this feature, which I initially thought was right here, just kind of extended off of it, just had moved that much, but that's not where I have it anymore, although it's still, I guess, possible that it's certainly possible that I did not arrange these right, but I still think that because this current fits through pretty well, I think this is probably actually pretty accurate. Surprisingly, that I, like, within a day, I'm like, yeah, I think this is pretty accurate. But because of this, essentially when the current from here going this way, like if we just assume based on that there's a current coming in here, like assume, like pretty much we have to decide which way the current's going, but like if we say there's generally a current coming in this way that's colliding with a current coming in this way, and has like a center point generally here where it divides away to the two sides, and it looks like it deflects more of the energy maybe this way than this way. So it generally goes this way, but then it like has a secondary generally going this way current. So we have like these two sides of this current that then continue. And so it's interesting, this current, like, it can split here, it can go between here, and it can go directly into that, like, splitting trident type thing in the Maui island, and continue through, though, through that, like, region where it continued, which then, essentially, this wraps around here, and probably also goes through here, like, cutting this way. This stream goes both that way and this way. But by going this way, it begins to just pretty much bubble this region, which kind of makes sense. Like this generally makes sense, and then over here makes a lot of sense. Like it begins to bow out quickly into like an arrow, like pushing. It's almost like pushing with a larger surface area to push from, but with a focused current to push with. And it pushes into this, and like bows it out, and just takes away the strips away material in the process, because this current's also going like out this way, or maybe around this way, because of around sphere, as I'll mention. I believe this formed as a sphere. It did not form as a flat surface on the earth, basically, that was as we see it today, where there's island. It formed as a sphere, which had currents coming in the poles, and it was then having the current wrap around the sphere. So it wraps around, basically going along the equator, and up here, like deflecting around things, but generally going along the equator here. This is a little confusing because it branches off. It actually branches off. It looks like I drew it this way, but it actually just branches off. That's why I drew this arrow back here. So it's actually going this way and branching off. And then I drew these arrows. I'm not completely sure if I was accurate on those, because initially I drew an arrow here, and that's why it's wide like that, because essentially I decided this current comes across here. Mind you, this vibrates out of balance, so then when they re-merge, they vibrate out of balance again. One of them comes straight across and continues straight across. The other comes around and generally continues down this boundary. And so the curvature of the currents kind of makes sense along this region as well. And then they just get through, and when they get through, though, like it takes this large landmass of all of Hawaii and just begins to like fan it out into this, like, so almost like it rolls around into like the shallogram of the Hawaiian island. Had features like this, where it had this like wrapping around in some fashion. I didn't quite, like, maybe here wraps it just here up to here. Like let's go to open. Puzzle attempt. Let's save it as attempt 2. Attempt 3, I guess, whatever. Okay. I just generally want to just take this chunk. It doesn't even matter if it... This chunk, and mind you, this is a sphere, so it doesn't actually connect like... Oops. Maybe I can do it like that, where essentially I just connect to the bottom instead of the top. To show like both sides of it. Essentially where this here also is over here. We got a visitor. Puppy visitor. Hey puppy. He likes to bark. So almost like this can also connect in there, which it kind of does fit in there. Just assume that like it's more rounded, like where it opens is because it's a sphere. It formed as a sphere. That's Does that make sense here? This looks a little too like varied. This here looks generally like related. This like here. Maybe it's more like this, like kind of in there. And this is more up here, like that. That there's just a way bigger space here for like maybe this, I don't know, to follow also over here somehow. As it was though. I don't know if that makes sense with as I had it. No. This almost has to be the other side. Like here. I don't know where I had that. Here. I don't know if that... This would even like appear kind of like one of these like triangle openings where it kind of creates space and just readjusts the radius and the angle of the terrain because it's pretty much on a was forming on a sphere that became flattened. Okay, let's go back to here and just real quick go through some more things. So generally speaking, the current, if this is true, the current continues across all the way through, but then it runs into the resistance of this current wrapping around that's putting pressure this way and causing like this region. So this region's full of currents, but this current wraps physically around the sphere and then comes into the region where it collides with the currents and wraps off this way, going over here. Which I believe then plays into coming in this way, here. So like these currents just wrap around here, generally speaking, in this region. And then they just kind of get lost in the intermixing of the main currents, so it's unclear if they just like... Maybe they cross over some more in some ways that are detectable that I haven't looked for. But this appears to play into that volcano chain there, or single volcano. I think they called it a volcano, even though it looked like many. Also, this here, I didn't draw it, but I was just thinking it not too long ago. Kind of trying to draw on my paper, my notebook. Why isn't it working? Kind of going like this way. So there's really a third position there. So back here, there's this one current coming in here. Another current generally coming in here. But then just kind of wrapping around here as well. And this one just dot 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 goes that way. Probably generally goes that way and becomes a little more focused. Which then I believe wraps in along this boundary maybe. I guess I can't draw on that layer directly without selecting it or combining these into one. It's okay. It kind of generally goes across there from over here, though. These ones go over here. I know. And even look like they make some kind of S current by wrapping around a sphere that was forming. And then the current coming up here, this way. Again, cuts through here. I believe I drew it like that. Yeah. And through here. So, this one that goes sideways off this way, which, I'm like, why? I drew it. I drew it, but it's not drawing on it for some reason. This one, also, maybe I need to select all the layers and just merge them as one. Group layers. Layer, merge group. Okay, there we go. There. Okay, now. Maybe that also. But this, generally, like, back that way. Almost like there's a collision here playing into it. But, like, this one definitely comes this way. And continues this way. And separates a little. I wonder if this one that separates, though, kind of goes over here. And maybe another current comes in this way. Running into this cross current type region. Does that make sense? Not sure if that makes sense with this one. Like, this one's really over here. Also, like, it's literally also over here. It's very hard to do this without an actual sphere surface to put these on. Or at least like a cube, something that's, or like a six-sided kind of structure of a sphere that's not quite like rounded, more just flat sides. Dodecahedron or something like that. I think that's the right word. Pardon me. Let me look it up, so since I don't know, like with certainty, yeah, something like that. Maybe with six-sided sides or whatever. But generally, like something that any polyhedron with 12 flat faces. Okay, something of that nature, though, that formed initially, because initially when this was happening, when these two currents were colliding. Really, what was happening was it was underneath Australia producing this. Nuclei imprints, this magnetic field. So there's pretty much a current, two currents colliding here. Underneath, generally speaking, Australia at the time, over here, but forming this ammonite. I think that's the next one, forming this ammonite structure that at the end, the final chamber, Australia rests on it as a nucleus, with a supportive nucleus over here as well, somewhere. I want to say there, the lower jaw. Literally, supportive nucleus. And so, like, out in the Pacific, where the currents were colliding, was here. So my thoughts are the currents were colliding here, producing a physical ball that was generally here, generally, at the time. Like, once something happened, like, the ball that was forming here, then, like, rested here and kind of splattered out. Like, it just unrolled. It was like how they find trilobites rolled up. Makes no sense. Like this. It's pretty much like this. Something of this nature. I'm sure there's trilobite connections between Hawaii as a whole and trilobites, because they're not fossils, they're just current flows that on different scales look different ways. And on this scale, it looks like a rolled up trilobite, but on this scale, it looks like here's an eye, maybe here's an eye, maybe the positive negative here are basically two eyes of the trilobite. Maybe this is like the trilobite head. This is like the spine of the trilobite back this way, and like arms, maybe even some, or like legs branching off somehow, producing the legs as through the side currents. Okay, so hopefully, I'm gonna stop, because obviously there's people here and I gotta do stuff. I gotta participate, be a member of the family, but hopefully that made sense, and I'm pretty sure that I'm onto something. So look forward to when we continue to talk about this. Yeah, so there's that. Didn't expect to find that. Did not expect to find that, but there it is. Sphere Hawaii. When Hawaii was a particle. Maybe I'll call it that. Alright, see you guys soon.